wait till we let people in.
Okay, so just tell me when to go.
Okay, people are filing in. Okay, we are ready to begin.
Okay, thank you. So something a little different today. We're going to take a look at the year that just went by. But for those of you who may not be familiar with this program or myself, I direct McGill's Office for Science and Society, and our mandate there is to separate sense from nonsense. And as you can imagine, that is quite a challenging task these days. Well, anyway, we have left 2021 behind. Good riddance, many of us would say, because this past year obviously was dominated by that virus. And we're kind of sick of looking at that and talking about the spike protein and talking about what it can do. Certainly, this virus has put a shadow on the world and has changed our life. So there's no question that when we review 2021, we will have to talk about the virus to some extent. However, there certainly were other events that we have to discuss when it comes to 2021. And one of those took place right at the beginning. And that, of course, was the infamous January 6th business, where people wanted to stop the steal. The steal, of course, refers to the American election that, according to former President Trump and his cronies, was stolen. As we know, there is absolutely no evidence for that, basically total nonsense. But that nonsense, nevertheless, precipitated that infamous attack on the US Capitol. And we've seen the pictures, we've seen the videos, we've seen the sickening photographs of this crazy guy standing in Congress. We saw them parading through the halls of Congress and fighting with the police, and just an absolutely horrific event in American history. Now, what scientific context is there here? There actually is some. And I want to spend just a minute talking about that because it is the issue of mob mentality. People will do things that they would never do as isolated individuals, but will do them when they are part of a mob, because it kind of gives an idea of invincibility. And also, you're pushed on by the fact that there are all these people around you who are agreeing with you. So we saw mob mentality there on January 6th, based on no evidence whatsoever. There's absolutely zero evidence that there was any problem with the results of the election. But these people, in their own echo chamber, have convinced themselves that that was the case. And they spurred each other on. This is the mob mentality. Now, this, of course, is not the first time that something like this has happened. If we look back in history, there are many, many occasions where mob has ruled. If we go back to 1692, and the classic Salem witch trials, I mean, obviously, This also had no scientific basis. There's no such thing as witches. But the population of the town of Salem basically was bewitched into thinking that witches exist. And this was mob rule. They basically egged each other on, and 21 people lost their lives because of this. Then, of course, there was the classic case of the French Revolution, where people were out in mobs cheering the guillotining of hundreds and hundreds of people. Now, that is something that they would have all, I think, been repulsed by if it was their own individual experience watching something like that. But when you're part of a mob, then of course there's this mob rule, and they stimulate each other. And there, in other cases like that, perhaps the most horrific case of all, of course, what happened in Nazi Germany, where intellectuals were convinced about the fact that Jews were ruling the world and were undermining German society. Obviously, no evidence of that, but when mob ruled, we know what the effects were. In the United States, the classic Joe McCarthy era, when people were suspected of being communists, and they were accusing each other. Now, individual would not accuse an individual, but when people got together, they made up their own accusations against individuals. Again, the mob mentality. We see this also in the stock market. The stock market goes up and down because people get advice from others, and eventually they become a mob and rule over the stock market. But of course, the most interesting aspect here is what we have noticed with the internet. Now, the internet, of course, is fantastic. It connects people in the world. It gives us access to information of all kinds. And, this has certainly changed our life. But basically what we have here is the possibility of worldwide mobs who begin to agree with each other and echo each other's sentiments. And before you know it, you have the nonsense coming out everywhere about Trump having won the election. And most Republicans today, which is millions and millions of people in the US, are still convinced that Trump won, with no scientific background to this hoax. Really, it's quite stunning. Now, of course, this internet mob mentality is not only about Trump and the stolen election. We see this also with COVID. I mean, unbelievably, there are people out there who say that this whole COVID business is a hoax cooked up by the deep state, whatever that may mean, for some reason, which is totally unclear. So this past year was dominated by the virus. It was dominated by the election nonsense. But what links all of this together is the growth of misinformation and disinformation. Now, misinformation is just the spreading of false information. And often the people who believe the information to be true will spread it. Disinformation is different. This is information that is deliberately misleading, usually because there's something to be gained by spreading this disinformation. This past year, the #1 misinformant on the web, although I think he can be accused of disinformation too, because he sells all kinds of stuff. So that's the bottom line there. But anyway, we're talking here about Joe Mercola. Joe Mercola is a former osteopathic physician who now runs what may be the most popular so-called health website on the internet. He is against vaccines. He is into every conspiracy theory. And he's got a huge influence. I look on Joe Mercola as the devil because of all of the mischief he causes. And the number of people who are sick because of this man and who have died because of this man are in large numbers, because he has convinced so many not to get vaccinated and to instead use his ridiculous treatment supplements that he sells. His politicking is also outrageous. This is on his Mercola website, article supposedly written by him about how Dr. Fauci is misleading the world. Well, no, he's not. It is Mercola who is misleading. And his book, which unfortunately has become very popular on Amazon, I even hate to talk about it, is just nonsense piled upon nonsense with all kinds of agendas from which he can make money. Now, Mercola is not the only one who is into this business of dispensing ridiculous information. This past year, we also saw the video Plandemic by Judy Mikovits, who actually at one time was a respected scientist. This video had millions and millions and millions of views. Outrageous things being said here. Wearing the mask literally activates your own virus. You're getting sick from your own reactivated coronavirus expressions. Why would you close a beach, she asked. You've got sequences in the soil, in the sand, whatever that means. You've got healing microbes in the ocean, in the salt water. That's insanity, she says. Well, saying that is insanity. And then, of course, she accuses Dr. Fauci of being involved in some kind of cover-up. This is very disturbing that this kind of stuff gets so much attention and so much publicity. Again, there's more. Dr. Madej came out with her own video. Again, she is also an osteopathic physician, and she is totally against vaccines. In fact, she says that vaccines are dangerous, and if you've gotten vaccinated against your will, then you better detox yourself. And she's got ideas about how to do this. You got to take a bath. And you take a bath in baking soda and Epsom salt, and this will detox you from the effects of the vaccine. It's actually hard to keep from laughing while you talk about nonsense like this. And then there's Dr. Sherry Tenpenny, who thinks that the vaccines were put out in order to depopulate the world. And again, a legitimate physician. This is what is so mind-boggling, that you have people like Mercola and Madej and Tenpenny who have proper scientific training, and they have certainly fallen off the cliff in terms of their mental capabilities. Tenpenny even suggests that if you get vaccinated, your body is going to become magnetic. And they do these demonstrations whereby coins stick to the skin. Again, you just have a little bit of sweat on your skin, and that will be enough of an attraction for coins. I mean, this is just absolute nonsense. The vaccine does not make you magnetic. Perhaps somewhat even more serious than this sort of laughable stuff are the people who are selling fake COVID cures. And in this case, these Americans eventually arrested in Colombia, but by that time they had caused a lot of harm in the US by selling what they call is their miracle mineral solution, which is a solution of chlorine dioxide, a bleaching agent that will do absolutely nothing for COVID-19. But they goaded people into coughing up large amounts of money to buy a non-existent cure. And then there was this homeopath who was selling fake vaccine cards. And as you probably know, we today have an onslaught of people who have fake vaccine certificates on their iPhone. You can buy this stuff on the internet. Then we had the promotion of ivermectin tablets to treat COVID-19. Again, there is just no scientific evidence behind this. Ivermectin is a very legitimate drug used to treat parasites, but study upon study has shown that it does not work against COVID-19. It's not only physicians who have these strange views about what should do for COVID or to try to prevent it. Athletes have a huge following. They are put on a pedestal because of their athletic talents. And then people think that because they're famous, they really know what they're talking about. So you'll remember this past year when Aaron Rodgers, quarterback for Green Bay Packers, claimed that he had been immunized by taking some homeopathic product. There is no homeopathic product that will immunize you against COVID-19. There's no homeopathic product that will do anything for you, because by the very tenets of homeopathy, homeopathic products do not contain anything. They are made by sequential dilutions of a substance, and by the time that it's down to the final dilution, there's nothing of the original left. Then we had Brooklyn Nets great basketball player, Kyrie Irving, sitting out games for which he would have been paid hundreds of thousands of dollars. He sat them out because he was unwilling to get vaccinated. And just now we have the whole saga of Djokovic, and he eventually was now allowed into Australia, originally not because he is not vaccinated, but he claimed to be exempt because he had COVID, and therefore supposedly he had enough antibodies. We'll see how this plays out, but he apparently is going to play in the Australian Open. I always liked Novak Djokovic, and it's really it's very disappointing that he has this anti-vaccine stand, especially because he pays so much attention to his health. He's very much into nutrition, obviously keeps himself in perfect shape, and it's hard to understand where this idea of being an anti-vaxxer comes from, because what we do know is that vaccines work. They don't work quite as well as we would like to see them work. They don't work quite as well as originally it looked like they were going to work. But that is not surprising, because when you do the original studies on a medication, those studies are done over a short period. 3 months was the original Pfizer and Moderna tests on these vaccines. That's when we saw the 95% efficacy. Those kind of rates never translate into long-term effect when the stuff is out there in the public. But nevertheless, the vaccines work. We know for sure that they keep people out of the intensive care units, and that is what really matters. Unfortunately, we now know that 2 vaccines are probably not enough. You need the 3rd booster. But the evidence is very solid that people who have had that 3rd booster are not likely to end up in the intensive care unit. And really, that's what it's all about, because we can all handle cold-like symptoms. It's uncomfortable for 5 or 6 days, and I mean, you don't want to have it, but it is not a life-threatening situation. So that's really the real benefit of the vaccines. But when you listen to the quacks, and unfortunately, science now is at the mercy of the quacks. It's a tsunami of misinformation that is enveloping us. And they muster their ammunition. And unfortunately, the anti-vaxxers and the other sort of quacks are very good at what they do. I'll give you an example. In the United States, there's a program called the Vaccine Adverse Event Reporting System, which was organized in order to give some early warning in case there is some issue with any vaccine. Now, this was not instituted for COVID. This has been around for a while, because there is always some risk with any kind of intervention, including vaccination. So the whole idea behind the Vaccine Adverse Event Reporting System is that anybody who got a vaccine and believes that there was any sort of consequence, negative consequence of that vaccine, they should just report it here. It does not mean that they know for sure that this was a cause and effect relationship. So anyone can report anything here. And there's no filtration. So this website was just designed so that researchers can keep a lookout in case there is something systematic that appears. But anyone can post anything. So for example, suppose you've just had the COVID vaccine, and tomorrow you find out that you have diarrhea. You can report this. You can send you can go to the website and enter your data saying that you had the vaccine yesterday and today you have diarrhea. That's all. Nobody looks at this to see, is it possible that this is a cause and effect relationship? This is just data that eventually researchers will scrutinize to see, are there all of a sudden thousands and thousands of reports of people having diarrhea after a vaccine? Then it is something to pay attention to. But in this case, how do you know that that diarrhea was caused by the vaccine, not by the E. coli tainted lettuce that you ate yesterday, which is of course much, much more likely. So these individual reports on VAERS are absolutely meaningless, except that the anti-vaxxers look at that and say, look what people have reported. And they show you all of these horrible, horrible things. It's misinterpretation of information. I'll give you an example here. It turns out that 98% of patients in hospital with COVID-19 use toothpaste the day before onset of symptoms. So, is that enough information to allow you to conclude that toothpaste causes COVID? Well, of course not. It would be absurd. Yes, it's true that 98% of patients in hospital with COVID-19 use toothpaste the day before onset of symptoms, but so did the rest of the population who did not come down with COVID, because 98% of the population brushes their teeth. But as you can see, you could post this on VAERS. You could say that you had your vaccine, and the next day you had a toothache. You could post that and suggest that there may be a link. I mean, it's just nonsense. So this is just absolutely wrong. But because of this lack of filtration on that VAERS website, people can go there and make all kinds of connections that don't really exist. All right, let's get to something a bit more positive. Can the antiviral medications that were introduced this past year keep people out of the hospital? The one that got a lot of press first was Merck's molnupiravir. And of course, when something like this is put on the market, it has to be backed up by data, as it was. But once again, it is almost always the case that the early data looks more optimistic than what actually plays out in the marketplace. And while certainly there is some efficacy with this drug, it doesn't look like the initial high hopes are going to be met. Paxlovid by Pfizer looks better. Again, here the data seems to be more solid, and it seems to it seems to be backed up once it's out in the general population. But again, the best way to stay out of the hospital is to make sure that you're vaccinated, and of course exercise all of the safety rules that we've heard about so much, which of course means distancing yourself, wearing masks, etc. Every year, as you know, Nobel Prizes are awarded, and it's always interesting to look back on a year to see who got the Nobel Prize that particular year. And I always, of course, look forward to the Nobel Prize in chemistry. And this year it went to Benjamin List of Germany and David McCallum of the US. And the Nobel Prize is generally awarded for sort of lifetime accomplishments, but often the committee will pick out one specific accomplishment. And in this particular case, the chemistry Nobel Prizes were awarded for the work that these two researchers did on the subject of catalysis and catalysts. It is hard for someone, of course, who does not have much of background in chemistry to appreciate how important catalysts are. But without these substances, our life essentially would be impossible. Catalysts are substances that allow a chemical reaction to proceed much more quickly than it would proceed in the absence of the catalyst. Usually it would proceed so slowly in the absence that the reaction is not worthwhile even considering for any kind of commercial application. There are thousands and thousands of different kind of catalysts. They are used in drug manufacture. They're used in the manufacture of plastics. And our world could not function without catalysts. I mean, they're involved in food production. They're involved in pesticide production, cleaning agents. I mean, catalysis is fundamental to chemistry. So a very well-deserved honor. The Nobel Prize in medicine was again shared in this case by David Julius and Papadopoulos. And here the research focused on our taste and our smell and how these work in the body. And that can be very important, especially, I mean, these days, as you know, one of the consequences of COVID-19 is the loss of taste and the loss of smell. So it's very important to know how these body functions work. So David Julius, for example, did a lot of work on hot peppers and you know, how we sense these and the active ingredient, a compound called capsaicin, and what it actually does in the nervous system, why it gives us the sensation of heat. So those were the Nobel Prizes in chemistry and medicine. This past year, we also had a lot of excitement in the space race. Now, at this point, the space race is not between the Soviets and the Americans, as it was in the early days in the 1950s, when the Soviets, of course, won the initial battle by putting Sputnik into orbit. Today, the race is more in between companies who want to get into the business of space tourism. They want to send people into space, a lot of money involved there, and make a business out of it. A lot of publicity this past year to Blue Origin, which is the company that was started by Jeff Bezos, one of the wealthiest men in the world. Now, the rocket that is being used looks somewhat different from the rockets that we've seen. It's different from the Atlas V that put men on the moon. But the chemistry involved is very similar. You can see the capsule at the top, which can hold up to 6 people, and obviously the engines at the bottom. But the rest of this vehicle is just a large container of fuel. There are 2 containers, actually, one of liquid hydrogen and one of liquid oxygen. And when these come together and ignited, the product is just water, so it's pretty environmentally friendly in that sense. And the water comes out of the vehicle under high pressure and steam, of course, and that propels the vehicle in the opposite direction. Now, the capsule atop the Blue Origin does not go into orbit around the Earth. So this is relatively a short time spent in space. Here's basically what we are talking about. So the vehicle is launched, and you can see the path that it will follow. And at the height of this path, it reaches about 100 kilometers from ground level. This is the so-called Kármán line, which is more or less accepted to be the beginning of space, because at that height, there's no longer any air left. Now, it's not like there's a sign there saying space begins here. The air begins to peter out, much lower than that. But by the time that we get up to 100 kilometers, there's essentially no air. The capsule then begins a free fall. And this is like being in an elevator that has broken and is falling down. And you experience weightlessness for a few moments. And then the capsule lands by airplane, by parachute. And the launch vehicle, the booster, is reused. It can land by itself, as you can see. So this is really amazing technology. It was called New Shepard, after Alan Shepard, who was the first American astronaut in space. And the first flight of the New Shepard in the capsule had Jeff Bezos, his brother, and 2 other guests. And everything went well. It's not a long experience. The whole flight is about 10 or 11 minutes, and only about 3 or 4 minutes are spent in weightlessness. Now, the first real space tourist after Bezos, who of course heads the company and his invited guest, was William Shatner. Very good choice for space tourist, of course, because as Captain Kirk, he made history with Star Trek, and that, of course, was all done on a soundstage. But here he got the chance to actually go into real space. This was followed by another group of astronauts in the same capsule, including the lady that you see in the middle there. And that was an inspired choice because that is Alan Shepard's daughter. Alan Shepard was the first American in space. He did not orbit. The first American to orbit the Earth was John Glenn, following the Soviet cosmonaut Yuri Gagarin, who was the first man to go into orbit around the Earth. Alan Shepard's flight was very much like the New Shepard flight that we've discussed. That is, it was essentially just up and down, spending a few minutes of weightlessness, which actually he didn't even experience because he was strapped into the couch, so he was not floating around, and came back down to Earth as we know, on a parachute, landing in the ocean. So the New Shepard vehicle is just an updated version of what propelled Alan Shepard into space. And interesting that his daughter was now a passenger, and there she is. This is the picture that was taken at the time that Alan Shepard had his first flight. And so this is, family come full circle, pretty interesting. Well, a competitor in this business is Richard Branson. And Branson also almost made it into space. It's somewhat debatable because it's not quite clear exactly what height his vehicle achieved. But this was a different concept. This was a rocket plane. And the plane that you see behind Branson here was actually lifted aloft, attached to another airplane. And when it reached the appropriate height, it was released and its rocket engine ignited. So all of a sudden, this plane became a rocket going straight up. The rocket motor, in this case, was an interesting one. This is quite different from the New Shepard. The fuel here was a type of rubber called hydroxy-terminated butadiene. And the oxidizing agent was not oxygen, as it was in the New Shepard, but nitrous oxide, or laughing gas, as you may know it. Well, in the presence of laughing gas, which can provide the required oxygen, the butadiene burns with a very, very hot flame. The gases that are produced are expelled, and that pushes the vehicle to the edge of space. Now, here is the path that the Intergalactic, which was the name of Branson's vehicle, followed. So as you can see, takeoff is attached to the plane. It is then released. The engine is ignited, and it reaches it didn't quite reach 100 kilometers. So there's some debate about whether or not Branson really should have his astronaut wings. But on the other hand, there's no parachute involved in the landing. The plane comes back as a glider, and it lands on the ground, ready to be reused. So this is another possibility for space tourism. But you got to have a few pennies in your pocket if you're going to partake of this. The fees run in the hundreds of thousands, if not in the $1 million, but there's a long waiting list for people to go into space. Anyway, this space tourism is a bit of a frivolous adventure, although I suspect it will have some significant spin-offs. But in a much more serious vein, what we saw this year was the launch of the $10 billion James Webb Space Telescope. This was criticized for many reasons. One of the reasons, of course, was the apparently outrageous amount of money that was spent here. One thing important to point out, that when we say that a project like this runs into the billions of dollars, you also have to ask the question, where was that money spent? This is not money that is lost in space. That money was spent here on Earth, paying researchers, giving jobs to thousands and thousands of people. So it's not like this is lost money. In any case, what an unbelievable project this is. And it's very, very difficult to actually get across the idea of how complicated this is and how many things have to go right in order for this to work properly. Now, the telescope itself doesn't really look the way that you would expect a telescope to look, because this is not an optical telescope. You're not looking with your eye through a lens. This telescope gathers light in the infrared region of the electromagnetic spectrum, and it concentrates it onto a detector, and that can be translated into an image. Well, this is really what this telescope looks like. And I suspect that you've seen pictures of this. Now, the yellow that you're looking at there, that is really the critical part of this telescope. That is the mirror that focuses the light onto the detector, which is in the middle. Why does it have this yellow color? Because it is coated with gold. This is the mirror itself is made of beryllium, but it is coated with gold, and it makes for a perfect reflective surface. Look at this. Here are some of the workers looking into the mirror, taking a picture of themselves. And you can see how good that reflection is. Now, this mirror is very large. In order to get it into space, it has to be folded up and then unfurled. This is what it looks like inside of the nose cone of the Ariane 5 rocket that was used to launch it. And it's like a jigsaw puzzle that has to be assembled in space. The capsule that carries the telescope is aboard a booster, which was made by the European Space Agency. And the chemistry here is interesting because it is very similar to a conglomeration of the New Shepard that we just saw and the Branson's Galactic. The main fuel is liquid hydrogen. So inside of the booster, we have the two tanks of liquid hydrogen and liquid oxygen. And you can see the very large tank inside. And you also see the booster. The booster on the side burns polybutadiene. And the oxidizing agent here is aluminum. It also burns aluminum, and ammonium perchlorate is the oxidizing agent. Anyway, this is such a complicated business. Thousands of things have to go right for a successful mission here. And you can imagine that at the point of launch, which happened to be on Christmas Day this year, there was tremendous apprehension in mission control. First of all, the launch itself had to go right, which it did. And this is not at all guaranteed. Basically, what you're looking at here is a controlled explosion. Anyway, it did make it into space, where the telescope was released, and slowly, bit by bit, it unfolded. And there are all kinds of motors that are involved in the unfolding. Each of these panels has to individually unfold. That requires a lot of ingenuity. And so far, everything has gone well, but still we are at the initial stage of this whole business. Just last week, one of the most important aspects or most important challenges was carried out, and that is the unfurling of this shield that protects the telescope from the heat of the sun, because the telescope has to be kept very, very cold. And this is an engineering marvel. This heat shield, you can see on the ground. This is, you see the researchers here working with it. It is made of material called kapton, very similar to mylar, that you see these silver balloons, helium-filled balloons, very similar. For those of you who are interested in the chemistry here, this is a polymer. It's called a polyimide. Anyway, it's really a classic space age material. But all of these layers have to unfold perfectly in order to protect the telescope from the heat of the sun. The telescope is launched away from the Earth, that is, in a direction away from the sun. And it will go into orbit around the sun at a position of about 1.5 million miles from the Earth. And that will take several weeks until it gets into that position. And then this telescope will go into orbit around the sun. And that's when we will start to see some visual images. But until then, we won't know if things are working properly, because there are numerous events that have to occur sequentially. And unfortunately, there's going to be no way to carry out any kind of repairs if something should go wrong. You may remember with the Hubble telescope, which was much, much closer to the Earth. It was in Earth orbit. And when something went wrong there, it was possible for astronauts from the space station to repair it. This is not possible with the James Webb. Incidentally, the reason it's called the James Webb Telescope is because James Webb was the head of NASA for about 9 years in the 1960s, and he was one of the masterminds behind the landing on the moon. Now, of course, the question is, what is all this sophisticated technology for? What are those billions of dollars being spent for? What can we gain? This is not something that we're going to have a practical spin-off from right away. We just don't know what kind of spin-offs will come from the technology that had to be invented for this magnificent project. But what this telescope will be able to do, essentially, is look back in time, because the light that it will be gathering will be light that left whatever is being looked at billions of years ago. The Big Bang took place, estimates are somewhere between around 13.5 billion years ago, which means that any light that was created then would have to travel for billions of years before we would be able to see it. Well, this telescope will be looking at light that left stars and galaxies billions of years ago. In fact, some of those stars may no longer even exist. I don't know nearly enough of, about astrophysics to know exactly what this is, what the benefits are going to be. But all the astrophysicists, of course, are tremendously excited about this. And it is indeed exciting. But for me, really, the most fascinating thing is the technology that was needed in order to make this happen. And it's just amazing, what human ingenuity can do. So in a sense, the Webb telescope will be looking into the past, because the light that it will see will have left those galaxies and those stars billions of years ago. Of course, we're looking more realistically at the present, and we're looking at the future. Some of the stuff that we've seen this past year does not augur for an auspicious future. One of the big problems that we have seen is garbage. We are flooding the earth with garbage, especially plastic garbage. Plastic is piling up everywhere. And of course, we have seen all the scary pictures where we see the interaction of wildlife with all of this garbage and what it can mean. Birds are gathering plastic garbage to make their nests. Unfortunately, they end up eating some of this stuff. And you can see this was found in the stomach of birds. We've seen the terrible pictures of these six-pack holders being, strangling birds. You look up in the air and you see the plastic. You look under the ocean, you see the plastic. And obviously, this is not doing any good to these creatures. And eventually, this plastic breaks down into very tiny particles we call microplastics. We see that being eaten by fish. So while the large pieces of floating plastic may do some harm, eventually the real problem is when these break down into microscopic particles that are almost invisible. And of course, we may end up eating some of those if we eat the fish. And you look at the rivers, you look at lakes, you see the garbage just piling up, bottles all over the place. And no matter where you go in the world, the plastic garbage is there. Now, of course, much of this can be recycled, but it means it has to be properly collected and processed. Unfortunately, it turns out that only about 25% of all these plastic bottles end up being recycled. And this past year, of course, we had another type of garbage added to the large pile. And these are the masks that are being thrown away. And obviously, there are all kinds of these masks. And when callously discarded, they end up in the water. This gentleman collected all of these on a beach. This, of course, has given a rise to the Say No to Plastic movement. Well, I understand what they mean here, but this is really an emotional reaction. You can't say no to plastic. If you want to say no to plastic, you can forget about airplanes, you can forget about computers, you can forget about operating rooms, you can forget about your cars, you can forget all about those cosmetics and cleaning agents that you buy, because these are all based upon plastics. So no, to say that we should ban plastic is a ridiculous idea. However, there are certainly some uses that we have to take a very close look at. And as you may have heard, January 1st, some European countries, France and Spain, for example, began to ban plastic packaging for fruit and vegetables, meaning that consumers in French supermarkets will no longer be seeing this kind of plastic wrapped produce. Now here too, it's more subtle than what people really have been led to believe, because you have to look at individual cases. Sometimes, certainly you can get rid of the plastic. Other times, it may be more environmentally friendly to use it. A classic example here are these English cucumbers, which are shrink wrapped in polyethylene. If you don't do that, then moisture is lost very quickly, mold can set in, and the cucumbers rot. Well, it turns out that when you throw away a rotten cucumber, which happens much more often if they're not shrink wrapped, you are putting a large burden on the environment. One discarded cucumber has a carbon footprint of 93 shrink wraps. So in this one particular case for the English cucumber, shrink wrapping makes sense. Furthermore, the polyethylene wrap can be recycled. And also there are shrink wraps made of polylactic acid, which is a material that biodegrades. A more significant concern is the one about the plastic bags. And of course, we heard a lot about that this past year as well. Eliminate plastic bags. All right, well, replace them with what? There is the notion of the biodegradable bags. Well, yes, you can make biodegradable bags. These can be made of again, polylactic acid, where the lactic acid comes from corn, or you can make it from sugar cane. The problem with these is that indeed they do biodegrade, but only under ideal conditions, which usually is in a commercial composting facility, not in a landfill, where due to the lack of oxygen, there really is no biodegradation. Also, you know, some of the silly advertising here, when these biodegradable bags are advertised as "I'm not plastic." Well, of course they are made of plastic. It's just a different kind of plastic. So it's unfortunate that the word plastic has sort of become a dirty word. Of course, it is better to carry your groceries home in reusable bags. That's for sure. But you know, you find out that in science, virtually every issue, if you scratch the surface, it becomes more complicated. For example, with the reusable bags, if you don't wash them properly, if you've stored some meat in there and you don't wash it properly, you can get bacterial growth, and then you put your vegetables into it. The next time you go to the store, you get contamination. Also, it turns out that people are overloading these bags, and they're causing injuries. Physios will tell you that they are seeing more and more injuries because people are carrying these heavy bags. Well, what about replacing the plastic with paper? That sounds like something that we should do, right? Why? Because paper is renewable. You get it from pulp, you get it from trees. Trees can be renewed. But when you do a cradle to grave analysis here, it turns out that paper, because of everything that is involved in processing it, it has a larger environmental footprint than the low density polyethylene. And this is what we have to do. You have to have a cradle to grave approach on these things. So replacing the plastic bags with paper is not an environmentally friendly way to go. In terms of the carbon dioxide that is released, which of course is the major greenhouse gas, there's more CO2 released from making paper than from making plastic. Of course, there are people who say, who cares? CO2 is not a pollutant. I love CO2. These are the anti-climate change people. These are the climate change deniers, and there are many of them. There are books about this, about how global warming is a hoax. No, it is not a hoax. Global warming is very, very real. The average global temperature is increasing, and we just learned, in fact, today, we learned that the last 7 years have been the warmest on record. And this has consequences. We've seen weather patterns like we've never seen before. We've seen the catastrophic tornadoes quite recently in the US, the devastation that they have caused in Kentucky. Now, of course, we don't have ironclad evidence that it is because of climate change, but it is a pretty good guess. And when you ask global warming scientists who study climate change, atmospheric chemists and physicists, they will tell you 97% of them will endorse the idea that humans are involved in global warming, that all of our activities are part of the problem. This doesn't necessarily translate to general population. You take a look, for example, United States, a high percentage of the population disagrees, about a third of the population disagrees that climate change is due to human activity. Well, it is. And this past year, we saw the Nobel Prize being given for this, the Nobel Prize in Physics, for studies on climate change. So this is real stuff. They don't just hand out the Nobel Prizes for nothing. And the researchers here showed, as they said, laid the foundation of our knowledge of the Earth's climate and how humanity influences it. Climate change is real and we are part of the problem. What can we do? Obviously, I mean, you've heard everything about driving less, bicycling, walking, and all of this. Yes, that will have an impact, but not a whole lot. I tell you where we can have an impact is with food. Zero waste is what we have to look for, because agriculture releases a lot of carbon dioxide, a lot of methane, and food processing also is not an environmentally process. Let me just give you a very quick background here. Obviously, when you're going to grow crops, you got to plow the land. You got to be using fuel to run that tractor. That tractor has to be manufactured. Then you plant your seeds. You protect them with pesticides. They have to be manufactured. You add fertilizer. That has to be produced. These are large industrial processes, large carbon footprints. Then you harvest your crops. You need the machinery to do that. Those machines have to be made. That too has a large footprint. And then whatever you're growing has to be taken away from the farm. It has to be collected, and then it has to be transported on highways. Obviously, a lot of fuel is being burned in this process. And then there's the processing of the food. A lot of machinery that is involved in that, a lot of heat that is involved in all of this processing. And food has to be packaged. You have to make the packaging material. Whether it's paper or plastic has to be made. That has a carbon footprint. You go to the grocery store, you buy your groceries, you put them in your car, you take them home, you're spending energy there. The food ends up in your refrigerator. Of course, you're spending energy keeping food cold. And then you're going to cook that food. That will take some energy. So you've already spent a lot of energy with all of this. And then, unfortunately, we end up throwing out a significant amount of the food that we make. This is especially the case in these restaurants where you can eat all that you want. Tremendous amount of food is thrown out. People take much more than what they can eat. Even in our supermarkets, a lot of food is thrown out because people want perfect produce. They will leave behind something that isn't perfect. Some of the produce doesn't even make it to the supermarket. They can't sell it, overproduction, which is really troublesome because so much of the world goes hungry. So farmers have to discard food. Some of this goes into landfill, where it degrades, releasing methane. Another problem is that we look at the dates on our food, and we think that if midnight has come at that date, this food is no longer consumable. No, this is something that we have to point out to people. You do not have to throw out food past its date, because those dates are so-called best before dates, which means that there might be a little change in the texture, a little change in the taste of the food after that date. It does not mean that it spoils. In order to know whether or not we should consume that food, what we need is an expiration date. And unfortunately, right now, the industry doesn't always give us that. They don't mind the best before date. because they don't mind that you're going to throw out food prematurely, because it means they can sell more food. So we need to do something about regulations here and enforce expiry dates instead of best before dates. So that's what has happened this past year. What the future holds, I can't tell you. If I were to make a guess, I would say that by this time next year, as far as COVID goes, I think we will be in a better position. We'll learn to live with it. It's not going to leave us, but the same way that we learn to live with the cold virus, with the flu virus, we'll learn to live with it. And when enough people have been vaccinated and enough people have been sick so they develop immunity, I think we'll have a handle on the situation. So that is it for our review of 2021. And hopefully when, if we get a chance to do a review of 2022 this time next year, we'll have some better news. All right, so I don't know if we have any questions, but if there are.
We did have one in the chat. We had someone asking about the telescope, of what it would be taking pictures of.
It will be taking pictures of stars and galaxies that were formed soon after the Big Bang. It will give us an idea of what our universe is really like, how vast it is, and also the possibility of whether or not there are planets circulating around those faraway stars that may have an atmosphere similar to us, where there may actually be life. So at this point, nobody really knows. That's the point of doing that kind of research, that you don't know what you're going to see. And hopefully we will benefit from it in some way. But undoubtedly, we will benefit from the technology that was developed to make all of this happen. The same way that the computers that we use and the cell phones that we use now derive their technology from the origins of the space program, when the real need was to make things as miniature as possible in order to be able to launch into space. So I think we will have some spin-offs, but it's hard to predict exactly what those spin-offs will be.
We're going to give people just another minute. We just got lots of thank yous in the chat. If anyone has questions, here's your opportunity. For those of you asking, this talk will be up on the Cote-Saint-Luc Library's YouTube channel if you missed any part of it. And how can they reach you if they have follow-up questions, Dr. Schwarcz?
My usual email, which is the classic McGill email, so it's Joe, joe.schwarcz@mcgill.ca. joe.schwartz@mcgill.ca, and the Schwartz is with a C, not a T.
Oh, and someone is asking if you will be resuming your video sessions about COVID and such.
We actually do that. We do once a month. We do a video session with my colleagues from my office called A Dose of Science. And the next one is scheduled for this Thursday at noon. But again, those can be seen. We record them and they can be seen at any time. So you can go to our YouTube channel and see all of the previous ones, and it's easy to find. Again, it's McGill/OSS on YouTube.
We have an excellent final question. Which scientific discoveries are you looking forward to in 2022?
Something that makes this damn virus go away. Although I think that's a bit optimistic. I don't think that we'll have any single breakthrough. That's just not how science works. Science plods along by small steps, not single breakthrough. So I'm not looking for anything monumental to happen, but I'm looking at incremental changes in more attention being paid to reducing waste, reducing garbage, more attention being placed on biodegradable materials, the higher emergence of fuel-efficient cars, especially electric vehicles. So I think it's more, small steps that are going to make our life better.
Thank you so much. And thank you all for joining us today. Thank you again, Dr. Joe. We will be happy to see you again next month.
Okay, bye.
Library. Bye, everyone.